In this tutorial, I will show you how to use the independent sites approach to perform fittings. In the section Project, go to New Fit Project, and now select the option Independent Sites. With these options, what we are going to be able to is to perform analysis of your isotherms considering an independent sites approach. That is, you will get thermodynamic information, the binding constants, and the enthalpy of the interaction between the ligand and each specific site of your receptor. So once we have selected the independent sites approach, we name the project and click on Save Project. Next, we have to add the data series we have to fit. So click on Add Data Series and select the isotherm you plan to fit. Click on Next. And as you can see, with the independent sites approach, there is no need to select any binding model. Instead, what we have is, into the fitting project, the option to select the number of sets and sites in each set that is going to be present in your receptor in the cell. For instance, in this case, by default, we have selected a number of sets of 1, which means that we only have one type of sites, and each set is going to be defined by a number of sites, the number n here, and is going to be characterized by a binding constant and a binding enthalpy. Let's assume that instead of just one set of sites, we have more than one set. So we can increase this number. For instance, I'm going to consider that we have two different sets of sites. Therefore, each set is going to be characterized by a number n. That means the number of sites of each set. And each set is going to be characterized by a binding constant and a binding enthalpy. As you can see in the table here of reaction parameters, by default, the number of sites of each set is a fitting parameter. This means that we don't necessarily need to know the number of sites of each set. And this is one of the advantages of the software affinimeter in this case. Like, we are going to be able to define the number of sites of each set in the analysis. However, if we already know the number of sites of each set, we can set it as a constant parameter. In this particular case, I already know that I have two sets, which one site per set. This means that my receptor has two different sites binding for the same ligand. So in order to consider a given value for each site, each number of sites, I just have to type in the box value egg of the corresponding number of sites, and I will type 1 for n11 and also 1 for n12. Next, I'm going to uncheck the box fit of both ends, and this way I'm going to consider both n, the number of sites, as constant parameters and equal to 1. Now I am ready to run the experiment. Okay, so here's the result, which is quite good. And let's consider in the case where I don't know how many sites I have in each set. So I will go again to Fit Settings, and now I will check the option Fit for N11 and N12. One thing you have to pay attention is that if we consider the number of sites as fitting parameters, we should keep the value Rm constant and equal to 1. Otherwise, the parameter Rm will couple during the analysis with the parameters n, number of sites, and the results or the analysis at the end will be over-parameterized. So keep in mind, if the n values are fitting parameters, keep Rm and Ra constant and equal to 1. We can run the experiment again. And check the results in terms of number of sites for each set, and each set has its own binding constant and enthalpy. The independent sites approach, as you can see, is a very useful tool when the time comes to characterize the interaction between polymers, for instance, a biomolecule or polymer biomolecule like DNA, for instance, or a glycosaminoglycan with a ligand, having the polymer in the cell and the ligand in the syringe, and where we have to define or characterize the interaction not only in terms of thermodynamic information, but also in terms of the number of sets and sites that are going to describe the interaction.